Hello viewers and welcome to the e-learning class. So today we are going to look at KCSE Physics Paper 1 and Paper 2 guidelines. That is the guidelines for physics theory papers. That is code 232-1 and code 232-2, the physics theory papers. So we are going to start by looking at the general information about physics paper 1 and paper 2, the general information pertaining to these theory papers. So the first point is that theory papers usually take 2 hours or 120 minutes. So theory papers take 2 hours or 120 minutes, and then candidates are advised to spend the first 10 minutes of their allocated time reading instructions and reading through the paper. So the candidates are all advised at least take 10 minutes or so, first of all, to check the instructions given, the number of questions, the marks maybe for each question, and maybe the topics are tested, the constants that you have been given, just scanning through the paper to understand how you organize your work and how you do each question, so that you can avoid overspending a lot of time in one question, or maybe you can avoid starting with the questions that you are not familiar with, because you can realize the questions that you can start with and the ones you'll finish up with. Then all questions are compulsory, hence should be answered on the spaces provided. In physics theory papers, you must understand that there are no selective questions. In other words, there are no optional questions, and that means you must do every question in that paper in that space that you have been given. And then candidates should read and interpret the questions carefully before answering them. So you must first of all read the questions and interpret them carefully. Read and interpret the questions carefully. And sometimes you can also underline the key ones in the question. That is to avoid any form of forgetting. So you must, sometimes you can underline the key ones and you can note the key ones in every question. Then do not invent your own question. In other words, you must answer the question given. You must confine your answer to answering the question given. In other words, you must avoid any form of giving extraneous kind of answers, or answers that are not relevant to the question being asked. Then another point is that understand the topic being tested and the concept being tested before answering any question. Understand the topic and the concept, and that's very, very important. You must know the topic being tested for every question and also the concept being tested. And this one mostly applies to the explanation questions, the kind of questions that you require to understand and explain. For example, you can be told a person walking barefooted on a concrete floor feels colder than a person walking barefooted on a carpeted floor. A person walking barefooted on a concrete floor feels colder than a person walking barefooted on a floor with carpet. Explain. So if you look at that question, the question seems a bit broad and maybe seems like it may have any kind of an answer depending on maybe the student or the candidate. But it should be noted that it cannot be so. You must understand first of all, which topic are they testing, and then which concept are they testing in that topic. So for example, in that particular case, you can realize that the topic being tested is heat transfer, and in that heat transfer, they are testing the thermal conductivity in solids. Thermal conductivity in solids. The topic is heat transfer in Form 1. and the concept is thermal conductivity. And to be more precise, it is a nature of the material. There are 4 factors that affect the rate of thermal conductivity. The factors are length of the material, nature of the material, cross-section area of the material, and also we have nature, length, cross-section area. Then we also have the fourth one is we have nature, length, cross-section area. Forgetting the fourth factor, maybe we can work with those 3. So we are saying in that case particularly, no, the fourth one actually is the temperature difference. The temperature difference, we have the nature of the material, length of the material, cross-section area, and the temperature difference. But to be more precise, they are testing the nature of the material. That means we have concrete and we have carpet. Which one is a better thermal conductor? Because each candidate should understand that for you to feel cold, it means heat has been drawn away from your body. In other words, heat has been conducted. It has been conducted away from your body, and that means you should be able to understand which one is a better conductor of heat. And in that case, now it tells you that concrete is a better conductor of heat than carpet. That is why it is conducting more heat from your body, or it is conducting heat at a faster rate. Hence, you feel colder because it conducts heat at a faster rate. In that case, you realize that there is comparative, the element of comparison, faster, greater, better. So you must also note that these key ones are very, very important. So in other words, we are saying for every question, understand the topic first of all before you answer the question. Know the topic being tested and also the concept being tested in that topic. For example, in that case, we have seen the topic is heat transfer, and the concept is factors affecting the rate of thermal conductivity or the thermal conductivity rate in solids. So it's very, very important, and that mostly that point mostly applies when it comes to application kind of question. So you must always confine yourself to that. So another point, identify the key terms or ones in the question. Some questions may require 2 answers, e.g. state and explain, narrow aperture or very narrow aperture, find the final velocity, and they state the direction the 2 bodies moved after collision. So you realize that these are all forms of questions. After maybe you have been given some statement or some paragraph of a statement, then the question now, find the final velocity and state the direction the 2 bodies moved after collision. So that means, first of all, you must calculate the final velocity, applying the principle of moments. Once you get there, the final velocity, then you must also know by saying that momentum before collision is that is the law of conservation of linear momentum. We are saying actually you're applying the law of conservation of linear momentum, whereby you are saying sum of momentum before collision is equals to the sum of momentum after collision. So we are saying now, in that particular case, you must realize that after finding the final velocity, you're also stating the direction the 2 bodies are moving after the collision. And that means now, these are 2 questions, whereby somebody may find the final velocity and forget to state the direction. So you must always underline the key terms where possible. Note the key terms, and sometimes you can also underline these key terms so that you can avoid forgetting the parts. Another point is that use the constants provided in the question or on the instructions section. The constants, and these constants are very many. We'll mention them later on. We are saying use the constant that you have been given. in either the questions or also the instructions. Then the oral papers are tested topic-wise. Candidates should be well informed on which topics to revise for each paper. That means you should know which topics belongs to paper 1 and which topics belongs to paper 2. And it's very, very important to categorize them into that. Remember, physics has 41 topics. That means you should be able to know which ones are in paper 1 and which ones are in paper 2. Remember, we also have a clip on that where so you can check a video on physics paper 1 topics and paper 2 topics. If you're not conversant, you can also check from our channel. Candidates should ensure they are physically set for the exam by, for example, taking a deep breath, relieving oneself, ensuring you carry all the tools you need in the examination, including pens, pencils, rubber, a ruler, mathematical set. Should carry everything that you require in the examination, and you should also be physically set. Let's look at now the second part, that is numerical questions. We are going to start by looking at the numerical. These are the calculation kind of questions. So number 1, use the correct formula. Use the correct formula, and the correct formula implies an equation having the conventional physics symbols. By that we mean, for example, rho equals m over v. Rho meaning density equals mass over volume. Rho equals m over v, and not d equals m over v. Remember, d is distance, so you must confine yourself to the right symbols, conventional symbols in physics. You must if you must use symbols that are not conventional, then you must define them, but I would advise that you use the conventional symbols. Correct substitution implies correct formula, but correct substitution does not imply a wrong formula is correct. That means if you replace various without the formula, for example, you can have the various but you don't know the formula, but you replace. For example, rho equals m over v. You have the value of m and v. You are looking for rho density, so you write rho equals value of m divided by value of v. So in that case, you'll get the mark for the formula. In other words, the formula is implied in that replacing. But if the formula you write is wrong, then you substitute correctly in the wrong formula, definitely the whole thing will be wrong. In other words, the substitution cannot justify the wrong formula. Abbreviations or short form in formulas are not accepted. For example, you can say ACM. In other words, anti-clockwise moment, for instance, equals CM, clockwise moment. Those kind of abbreviations are not accepted. So you must confine yourself to the right formula and the correct conventional symbols. Number 2, correct substitution. After we've said number 1 is correct formula, and we have said what a correct formula is. So number 2 is correct substitution. Candidate should convert the substituting values to SI units unless under special circumstances. So in other words, always work with the SI units. It's very, very important. I know by now any candidates in Form 4 should be able to know this. So you should always work with the SI units unless under few special circumstances. One, where the units are cancelling out, or in some topics where you don't require to use the SI units. There's some few topics or subtopics. For example, when you are working costing of electricity in kilowatt hour, not seconds. Capacity of an accumulator in cells and simple circuits in ampere hours and not ampere seconds. So there's some few exceptions, but always work with the SI units. And then candidates should incorporate the meaning of terms milli, micro, kilo, and mega in substitution. We have given you the value of each milli. That is 10 power negative 3. micro 10 power negative 6, kilo 10 power 3, and mega 10 power 6. It's important to know that, for example, if you find small m, mk, that is millikelvin. Small m, n, mn, that is millinewton. So in other words, what we are saying, if you find such kind of symbols before the units, there's a difference between a unit and that value of the symbol representing a number. For example, capital M, mn, capital M, capital N, mn, that means mega Newton. Newton is the unit for force. Newton is the unit for force, but m is a number. It's mega. For example, you can say I have 10k shillings. You realize shilling is a symbol, is a unit for the money currency you are using. But you realize that k is a number, meaning 10,000, 10k shilling, 10,000 shilling. The other one's kilo, represent 1,000. Then units may be ignored during substitution. That means you can just substitute the values directly. Number 3, the last part on numerical questions. So after stating correct formula, correct substitution, last we have correct answer. Stating the answer. How do you give the correct answer? 1, correct answer with correct unit, full mark. Correct answer, wrong unit, no mark. That's for the answer. If the unit for the answer is wrong, even the answer will also be wrong. Correct answer, no unit, half mark. That means correct answer, you have left the unit, then you get a half. Wrong numerical value with correct unit. Your answer is wrong, but the unit for the answer is correct, 0 for the answer. Your answer should never be in fraction, always should be in decimal form, and mostly at least 4 significant figures. I believe you all know that. Units given in conventional symbols, check for small or capital, except for those given in ones. So when you are giving the units in symbols, mostly you work with capital letters or small letters. For example, capital K, Kelvin, capital N, Newton, small s, second. So you should check which one do you work with, capital letters or small letters, when you are replacing in symbols. Ignore units at intermediate stages. Before you go to the final answer, you may ignore the units in the previous steps while you are working out. Ignore irrelevant equations and formula. There is no mark for correct answer from wrong working. That is self-explanatory. No mark for correct answer from wrong working. That is self-explanatory. So that is all about numerical questions. You may send questions and feedback on comments section. So let's go now to the next part. That is given constants. The constants. So candidates should use given constants in the question. For example, capital C for heat capacity, small c for specific heat capacity, G pull of gravity, E change of an electron, H Planck's constant, pi among others. You have Pascal among other. So atmospheric pressure, sorry, PA, atmospheric pressure. So we are saying all these constants that you are given, always confine yourself to the value that they have given you. But in case they don't give you, still replace the correct value, the correct conventional value. In other words, for example, if you're not given pi, you still know pi is 22/7. So you just replace 22/7. Maybe you're not given E, charge of an electron, but you know charge of an electron is 1.6 times 10 raised to negative 19 coulomb. So you can still replace the value even if you're not given, but you must check whether you are given. Stating given factors or items. state 2 factors or such. The number of points or answers is pegged on marks awarded. In other words, give the points as per the marks. If you're given 3 marks, you should state 3 factors. But mostly in physics, you realize that you are normally required to give 1 or 2. Mostly, state 1 factor, state 2 factors, mostly. So it's very, very important to check the marks so that you give the required responses. Then marking is done according to candidate's work from first to given number. That means if you are told to give 2, then you give 3. The first 2 will be marked. Then the third point, if it is wrong, it will be marked, and then it will deduct 1 mark from the previous 2 points. In other words, you are told to give 2 factors. For example, state 2 factors affecting surface tension. You state 3, whereby the first 2 are correct, the third one is wrong. Then the third one will also be marked, and then it will deduct a mark from the previous 2 correct points. In other words, what we are saying generally, confine yourself to the number of points that you are required to give. We are just required to give 2, just give 2. If you're just required to give 1, just give 1, because the extra point cannot be marked if it is correct. But if it is wrong, it will definitely be marked, and then it will deduct a mark from the previous correct points you have given. So avoid the extra points, just state the required number. Where there is contradiction in answers given, the candidate is denied marks accordingly. That is self-explanatory. For example, we are saying state 2 properties of a good thermometric liquid. Properties of a good thermometric liquid. Then you say number 1 should have a high boiling point. Number 2 should have a low boiling point. For instance, should have a high boiling point. Number 2 should have a low boiling point. Definitely the first point and the second point are contradicting each other. And that makes now the contradiction will be penalized. So mostly you should confine yourself in answers that are not contradictory in nature. In other words, avoid any form of contradiction. Only state the required number of points. We have already said that. Avoid extra or extraneous points. We have already given that. Rules on filling of tables. How to fill the tables. 1. Give the answers in decimals, not fractions. That means in the boxes in the table, should just fill the values in decimals. Units don't have to be included while filling the table. Mostly, remember, units are given in the table mostly. That means you just require to key in the values, the numbers, in maybe at least 4 significant figures. So you just require to fill the numbers in the boxes in at least 4 significant figures. But sometimes if it is terminating, for example, if the answer is 30, if the answer is 30, then you can just write 30 because there are no decimals there. But if there are decimals, then at least 4 significant figures can be more, 4 or more. Then rules on answering questions requiring aid of a diagram. Rules on answering questions requiring aid of a diagram. So 1, diagram drawn should be workable. That is very, very important. The diagram you draw should be workable. If the diagram is not workable, then it implies that explanation given is incorrect or it is not correct. In other words, if you give a diagram that is not workable, even if the explanation is correct, definitely you are explaining the wrong thing, and that means what you are giving cannot be understood. Diagram should use the components provided only. Do not introduce extraneous components. If you have been given the apparatus to use in drawing your diagram, definitely you should only use the apparatus given. You should not introduce an extra apparatus which is not in the procedure you have been which is not in the apparatus you have been given as a list to use. In other words, you must use what is given in the question only. Then the diagram should be well labeled. That is okay. For example, we have to verify Ohm's law. You're given the various components, the ammeters, the voltmeters, the coils, the wires, the cells, the switch, and all that. We are seeing that's the one of the examples of a diagram you can draw to verify pressure law or variation, hydraulic brake system. Draw the diagram and explain how it works. We have to find the diagram to find the heat capacity or specific heat capacity, among others. Generally, the procedure should flow smoothly and logically. And that means when you have given a procedure that explains how your setup works, then the steps should follow each other according to the way the steps are given in the book. In other words, you should follow the procedure in accordance to, if for example you have been given 4 marks and then you want to verify a certain law, then definitely you should explain the steps applying the apparatus you have been given, and you must confine yourself. You must understand when you are stating a procedure, you use the ones do this and that, not you will. For example, you can say take this, connect this, tap this, read this, record this. In other words, you are assuming somebody is there with all the apparatus. So in other words, for example, if I may give you a simple illustration, for example, explain a simple procedure to determine the position of COG of an irregularly shaped object. Describe a procedure of determining position of COG of an irregularly shaped object. So definitely I go to maybe let's say you are been given 3 marks. So the first point I will say, take an irregularly shaped cardboard and make 3 holes. Take irregularly shaped cardboard and make 3 holes. That's the first point. Hang the cardboard through the first hole alongside a plumb line and trace the plumb line through it. Hang the cardboard through the first hole alongside a plumb line and trace the plumb line through it. Then the third point, repeat step 2 for the other 2 holes. In other words, hang the cardboard through the other 2 holes alongside the plumb line and trace the plumb line thrice. Hang the cardboard through the other 2 holes alongside the plumb line and trace the plumb line thrice. The point where the plumb line traces meet is the position of COG, or the center of gravity. The position where the plumb line thread outlines meet is the position of COG. So in other words, you realize that in that procedure, you assume somebody is there with all the apparatus, so whereby you are telling him what to do directly what to do. In other words, you should figure out in the mind, like somebody is there with all the apparatus, you're just telling you to do this, do that, and so on, and then they're able to finish up the procedure. Rules on answering state and explain questions. So in state and explain questions, if the statement or the observation given is incorrect, then it implies even the explanation is also incorrect. So in other words, because you are stating and explaining, so if the statement is incorrect, or in other words, if what you have observed is incorrect, then even the explanation you will give thereafter will also be incorrect. So in other words, you must confine yourself to correct observation or correct statement for you to get the correct explanation mark. Remember, these two are marked independently, but we are saying the mark of explanation depends on the mark of how you stated or how you observed. Avoid giving contradicting statements. That is very, very key. The statement should be based on scientific principles and laws, as well as the accompanying explanation. So that means state the observation and explain the observation. You must state in accordance to a scientific law or principle. You cannot state from a layman's point of view. So in other words, you must give your statements scientifically and also the explanation. Rules for graphical work. So in theory paper, students are expected to interpret a given graph which usually has been drawn. That means mostly you'll be given a drawn graph which you are just supposed to interpret and also to use it to answer the questions. Remember, mostly it occurs in section 2, whereby you are given a drawn graph already. Then you are just required to interpret the graph and also to answer the questions. That's according to the new trends. So determine the gradient by picking 2 points on the line and substitute in the question for the slope. You determine the gradient normally. Of course, we know how to determine the gradient. You just pick 2 easily readable points and then you determine the gradient. And then you should know how do you replace the gradient in the equation. By the way, it's important to know that when you are dealing with a graph, you must understand what is the essence of a graph. What is the essence? What is the importance of a graph? And by that, I'll refer you back to Form 1 mathematics, whereby we normally say there are 3 forms of solving equations, 3 ways to solve equations. That is we have a linear method. We have a substitution method, elimination method, and graphical method. You have substitution method, elimination method, graphical method, and definitely that tells you that graphs are used to solve particular equations. In other words, what a graph can do, even a normal equation can also do. So it's just a method of solving a particular equation. That's what we are saying. You must understand what is the importance of slope when it comes to the equation you'll be given thereafter. Then the unit of the slope. The units of the slope, how do you know the unit for the slope? You just check what you are dividing in the y-axis by what you are dividing in the x-axis. For example, let's say in y-axis we have voltage in volts, x-axis current in ampere, voltage in volts, current in ampere. That means change in volts over change in ampere. That means change in volts over change in current. In other words, V over I, voltage over ampere, volts over ampere. And that means that is the resistance, ohm. Definitely that is a ohm because that is a resistance. So in other words, you'll be able to understand that based on what we are dividing. What we are saying, basically based on what you are dividing, you can either give in terms of direct units. For example, V over A, volts per ampere. Because you are dividing volts by ampere, you can give in the conventional, the very correct symbol. And that one mostly applies to somebody who understands what we said previously, the topic being tested and the concept. such that if you understand they are testing resistance and then you have realized you're dividing voltage by current, then you know V over I is definitely resistance in ohms. Then always read the scale on intercepts and understand its accuracy before evaluation and working. Of course, for you to before you interact with any scale, you must understand what is the accuracy of the scale. Is it 1 decimal place, 2 decimal place, also so and so on and so on. Give the correct units for the intercepts and relate the slope obtained and y-intercept value with the equation given. Give the correct units for the intercepts and relate the slope and y-intercept obtained with the equation given. In other words, what you are saying, the slope you've been given and the intercepts, they are very, very important when it comes to solving the equation, because sometimes we are given an equation in the form of y equals mx plus c. That means you need to replace m, which is the slope, and c, which is the y-intercept. Mathematically it is y-intercept, but in physics you'll have variance intercept, can be voltage intercept, resistance intercept, current intercept, depending on what is on the y-axis. So we are saying it's very, very important you understand how you replace those values in the equations that you have been given. You should be able to understand how you replace both the intercepts and also the slope. So we go now to the next part, that is rules on giving or stating the SI units. For example, you are told to state the SI unit of length, state the SI unit of charge, state the SI unit of heat capacity or specific heat capacity or capacitance or voltage. So when you are stating the SI units, you must give in singular form and also in singular form and in ones. You must state in singular and also in ones. For example, you can say SI unit of capacitance is farad, small f, farad. SI unit of time, second. SI unit of mass, kilogram. So we are saying you should state in singular and also in small letters, in singular, and in statement form in singular and also in small letters. Rules on drawing ray diagrams. Let's look at now the ray diagrams. Ray diagrams should be drawn using straight lines with a ruler and indicated using arrows to show the direction of light rays. That means for you to draw any ray diagram, remember ray diagrams appear when you're drawing in reflection and linear propagation and reflection in plane surfaces in Form 1. That's the topic in Form 1, like linear propagation and reflection in plane surfaces. We have in Form 2, reflection at curved surfaces. In Form 4, we have thin lenses. Those are three major topics where you need to draw ray diagrams, object, and location of the image. We also have others. For example, we have refraction in Form 3, reflection. We also have other cases, waves too. For example, reflection of waves and so on, where you're required to draw the ray diagrams. So we are saying you must use a ruler to draw the straight lines, and these straight lines must have arrows. Arrows are very, very important. Remember, any line without an arrow cannot be a ray. A ray must have an arrow. So you should be able to use a straight line with an arrow for a ruler. And a ray should always start from the tip of the object. That is for objects we are saying that, there are two types of objects. There are objects which are touching the principal focus, and there are objects which are hanging, whereby they are not lying on the principal axis. So in such a case, you should use the tips of the objects to be able to locate the image. Virtual rays do not have arrows and should always be drawn using straight line and dotted lines. Virtual, dotted. Real, complete line. Real line, real object and real image, and real object, image and ray. Real object, image and ray. Maybe you can call it Roy. There's a ray, object and image. Roy. Ray, object and image. If they are all real, then it should be complete line. Roy, complete line. Virtual rays, dotted line. Or virtual image, even the virtual image. Virtual ray or virtual image should be dotted. Remember, dotted lines don't have arrows, but complete lines have arrows, but virtual or dotted have no arrows, but complete lines have all arrows. Very, very important. So we can go to the next part now. That is our stating of laws, rules, principles, and the theorems. How to state the laws, how to state the rules, how to state the principles, and how to state the theorems. So they should be stated as they are without any alteration, additions, explanations, or misquotations. Let's direct to the point as they appear in the book. The conditions should be included where possible. It's important to know that there are laws which have conditions. For example, state the Hooke's law. State the Hooke's law. It states that for a helical spring or any other elastic material, extension is directly proportional to the force, provided that elastic limit is not exceeded. It states that for a helical spring or any other elastic material, extension is directly proportional to the force, provided that elastic limit is not exceeded. So you realize that in that case, there is a condition there whereby we are saying elastic limit should not be exceeded. That means when you are stating such kind of a law, you must also state the condition attached, the condition under which that law applies, or that rule, or that principle, that theorem. Remember, each one has a meaning. There's a slight difference when it comes to laws, rules, principles, and theorems. But either what we are saying, all these, you must state them exactly as they are, and you must also avoid explanation or additions or misquotations or alterations. Avoid all that, and also state the condition where possible. It's very, very important. Condition where possible, no alteration or addition or misquotation or explanation. Just state them as they are, and there are very, very many. For example, you have kinetic theory of matter, Pascal's principle of moments, principle of the law of conservation of momentum. We have Pascal's principle. We have Lenz's law, Faraday's law, clock rule, and so many. the frame means right hand grip rule, frame means left hand grip rule, and so on and so on. We are saying there are very, very many, which you should also be able to understand. Then we go to the next part, that is rules on questions requiring use of scientific concepts. Rules on questions requiring use of scientific concepts. Avoid partial or unclear answers. Answers should be specific and complete. Partial or unclear answers should be avoided. In other words, you should give clear and complete statements, scientific statements. Use comparative language, very, very important. It's important to note that in physics, comparative language is very, very essential and very, very key. For example, you can say faster, more, higher, greater, less, smaller. For example, what has more adhesive force than cohesive force? What has more adhesive force than cohesive force, while mercury has more cohesive force than adhesive force? You realize that that is a statement that as a comparative, the element of comparison. For example, you can say water, gets heated faster. The glass get heated faster. Water get heated more. What we are saying, comparison is very, very important. Remember, there's a big difference when it comes to fast and faster. Because when you're saying fast, of course, fast is very, very unclear. For example, somebody can tell you, I've seen a very fast moving car. But you realize that it may be fast to him because they have never seen a car moving faster than that. But to you, it may not be fast. So we are saying these ones of the simple form. Simple form is dependent on who is saying. For example, I've seen a good girl. Goodness depends on the beholder, the eyes of the beholder. You realize that cannot be implied to apply to everybody. So what we are saying, faster is very precise because it means faster when you compare with this other one, whereby everybody can see there is a difference there. More, everybody can see this one is more than this because we are comparing two things which are clearly visible. Greater, everybody can see these are two things, but this one is greater than this. So what we are saying, you must use the comparative form and not the simple form, because in simple form is very indefinite and cannot be relied upon, because simple form is dependent on who is saying, whereby we are saying now, for example, if you say I have seen a big force, this is a big force. It may be big to you, but somebody else not big. So what we are saying, it depends. That's why we're saying you must avoid simple form, but always confine yourself to comparative form. Then distinguish is not the same as differentiate. Distinguish is to differentiate in terms of definitions. So we are saying when you are distinguishing, you are using definition. For example, distinguish between mass and weight. Distinguish between mass and weight. Mass is the quantity of matter in a body. Mass is the quantity of matter in a body, while weight is the quantity of pull of gravity acting on a body. Mass is the quantity of matter in a body, while weight is the quantity of pull of gravity acting on a body. So you realize that the keyword there is while, but now you are defining this one and you're also defining this one. That means but using the word while. Remember, for you to distinguish or to differentiate, whether you are distinguishing or differentiating, you must always use while. Alternatively, you may also use a table whereby there is a line in between. This side there is mass, this side there is weight. A table with the two parts, or you can also use while. Those are the only two ways of distinguishing or differentiating. But we are saying distinguishing is in terms of definition. But when it comes to differentiating, you use various forms of differentiation. For example, one, in terms of definition, in terms of instruments, as a measuring instrument, in terms of SI unit, you can call it DIS. The first three forms of differentiating: DIS, definition, instrument, SI unit. DIS, of course, those are three free points when you are differentiating things, because, for example, you can define this and that. For example, you can say, give three differences between mass and weight. Give three differences between mass and weight. Let's start with D, definition. Mass is the quantity of matter in a body, while weight is the quantity of pull of gravity acting on a body. Okay, the first mark. DIS. Let's go to I, instrument. Mass is measured using a beam balance, while weight is measured using a spring balance. You get another mark. S, SI unit. SI unit of mass is kilogram, while SI unit of weight is Newton. You get the third mark. So what we are saying, differentiating can be in terms of DIS, definition, measuring instrument, and SI unit. But there are other ways. For example, another difference, mass is a scalar quantity, weight is a vector quantity, mass is constant everywhere, weight varies from place to place, and so on and so on. So we are saying that's just a simple way of differentiating, but there are other ways. Rules on cancelled work. How do you deal with cancelled work? For example, you have done some work, then you realize you made an error, or you're not sure of that work, you have cancelled, maybe with one line. So if you give an alternative, the alternative will be marked. And alternative is the uncancelled work, the uncancelled. Let's say you have done two parallel work here. One is cancelled, one is not cancelled. The one which is not cancelled will be marked. But we are saying, if you have not provided an alternative, let's say you have done some work here and cancelled, but you do not give an alternative solution, then it means the cancelled work will be marked. In other words, when you are cancelling, you may cancel with just one closing line, diagonal, maybe one line, so that now in case you don't provide an alternative, then definitely the work you have provided will be marked, and then you'll be awarded the marks. Then we are saying, in case you give an alternative, definitely the alternative will be marked. But if there is no alternative, the one you have given initially will be marked. Then there will be no mark awarded for parallel work or guesswork. If you give two answers, let's say you have been given a question to calculate, for example, to calculate current, then you calculate in two ways, and you're getting different answers, and you leave the two ways there for the examiner to determine which one to mark. Definitely you lose all the marks, because now it means you're not sure of what you're doing, you are guessing. Remember, this is our science. We don't allow any form of guesswork, because this is our science, whereby we need serious engineers, serious medical doctors, and so on and so on. So we are saying you must be very exact and be sure of what you're doing. Rules on error transfer. How do we deal with error transfer? How do we deal with error transfer? So error transfer occurs when a wrong answer in a section of a given question is transferred into another section of the same question. Mostly applicable to structured questions. We are saying, let's say you have done a question, for example, capacitors in series or in parallel. Maybe the first Roman 1 you got the effective capacitance, total capacitance. Roman 2 you are required to find charge, total charge, whereby you know Q is CV. So you need the C, total capacitance above it there in Roman 1. In Roman 2, you need the answer for Roman 1, Roman 2. So what we are saying, if that answer in Roman 1 is wrong, then you use it correctly in Roman 2, then you get the full mark. If the answer in Roman 1 is wrong, but you use it correctly in Roman 2, then definitely you get the full mark. But if it is wrong, if it is correct and you use it correctly, you still get a full mark. But if it is wrong and then you don't carry it at it as it is, you alter it or you change it or you ignore it in Roman 2 and use another thing, definitely you'll miss the mark. So it's important, in case you're not sure of the answer for Roman 1 and it is required in Roman 2, just carry the answer you got in Roman 1 as it is, so provided it is an answer. It's an answer, just carry that answer in Roman 1 and use it in Roman 2. That is what we are calling the error transfer. The subsequent working with the current wrong answer will score the full marks as per the working and the question being answered. Never leave questions unresponded to, especially those with subsequent subsections. We are saying, suppose there are these structured questions whereby you have Roman 1, Roman 2, and Roman 3, and so on and so on. And in these questions, you realize that in Roman 1, you require that answer in Roman 2. Roman 2, you require that answer in Roman 3. Roman 3, you require that answer in Roman 4, and so on and so on. So we are saying, just don't leave any pattern responded to. Respond to every question. Even if you're not sure of the answer, just respond to that because you're required to carry that answer down here. So just respond so that you can carry that answer as it is to the subsequent section, whereby in case you missed Roman 1 but you use the wrong answer in Roman 1 to solve Roman 2 correctly, you get full mark, and so on and so on. So generally that is physics paper 1 and paper 2. Remember, we have said other than these guidelines, we also provided you a video on topics in paper 1, the topics that are tested in paper 1, and also the topics that are tested in paper 2. That means you can also check there, so that at least you can also get the general overview of what you need to revise on for paper 1 and also what you need to revise on for paper 2. But just to remind you, theory papers are very, very simple and it is very easy to score the 80 marks. It's very, very easy as long as you understand what you're doing and you are confident of yourself. That means you must always prepare well. Always put God first and work harder. Definitely put God first. Also work harder and then manage your time well and avoid anxiety. Avoid anxiety and confusion. Just ensure you have prepared yourself. Sit in a strategic position. Carry all the materials you require. We also gave you a guideline on how to prepare for an examination, or how to relieve tension before you do an examination. We've given you videos on that, so you can also check. Believe in yourself and sharpen your axe in good time. Very key. Just trust in yourself. Prepare. Others have passed and you're also going to pass if only you do what is required. So just believe in yourself. So you can reach us through the email address elearningclassroom1@gmail.com for you to get a pamphlet or a document of this, or you can also book it through the WhatsApp line provided. So that means always be free to reach to us. We'll be free to respond to all the questions you have in physics. So be free, and always you are most welcome to the e-learning classroom. Remember to subscribe and also to like our channel. So that's all for physics theory papers. Wish you a good day.